Hello. Oh, they're muted.
Yeah. So uh, yeah, there are a couple there are a couple of people here. So I wanted to like update stream how I update my Factorio patch, like large pages patch. Do you need some sort of narration? Wait, I just can just go coding. Or do
Yeah.
you like how I can actually give a description like how this entire thing works.
Mhm.
So and like do you need like explanation what is large pages, why they're important, like TLB and all this stuff?
So yeah, do you want to just sort of give a high level explanation of what's going on?
So yeah, like there is a concept called virtual memory in
Yeah.
computer science. So basically, when you have a like virtual space, each program have its own virtual space, and you have physical space, and like each virtual space is isolated, and so
Mhm.
you need and operating system need to map between virtual and physical spaces, and which is done by like operating system has a page tables, which like store a translation for each particular program between physical pages and between virtual pages and physical pages. But basically, it also means when you're accessing some memory in program, like memory management unit need to do like some additional lookups in those tables, translation
Yeah.
tables, and it's slow. Memory is already like biggest bottleneck in modern hardware.
Yeah.
And so there is a special cache called TLB, which basically caches this translation between virtual and physical pages, but it's small. I don't remember exact size, and
Mhm.
basically, if you access too many pages, like old pages will be evicted from this cache, and system will need to do this like full lookup again. And
Yeah.
to fix it, like, and also the default page size on x86 is 4 kilobytes, which was
Mhm.
selected back in 80s, and like in 80s it was perfectly reasonable size, but now it's very small for
Yeah.
current users, and so like 886 x86 supports multiple like bigger page sizes. Specifically, I think it supports 2 megabytes, which called large pages, and one gigabyte, which called huge pages. But by default, we are stuck with 4 kilobyte pages for
Okay.
stupid like backward compatibility reasons.
Yeah.
So, but you still you still can allocate those large pages, and it will help TLB because you'll have less pages, and you can fit more like
Yeah.
translation items into this TLB cache. So the problem, like the large pages, is not like it's not very good supported, especially on Windows. Like
Yeah.
in on Linux, you can, for example, you can pre-allocate like those pages, and IS won't use them for anything else. Or you have also concept of transparent huge pages. Basically, when application thinks that it deals with usual pages, but actually under the hood, system uses large pages transparently for the application,
Mm.
but there is no like such thing on Windows. And on Windows, we have to call special functions, like pass special parameters to allocate those huge pages, and it's not very reliable. So,
Yeah.
and Factorio itself, it's memory bound, and it helps like using large pages for memory allocations. It helps performance, and performance gains will be maybe around 10 to 15%, and UPS
Yeah.
gains. Well, I saw different numbers like between 8 on the internet, between 8% and like 30%. On my
Mm.
machine, it was about 10 to 50 to 15.
That's cool.
But Factorio itself cannot use like large pages because it wasn't coded to do this. But we can we can fix this sort of.
Yeah.
So the approach I chosen, I took a library called TBB. TBB itself
Hmm.
is trading building block. It can it contains like a bunch of trading related primitives like parallel force or like threads or mutex things like that.
Hmm.
And it also have a component called scalable allocator. And this scalable
Yeah.
allocator, it can use large pages for allocation. Well, upstream, upstream TBB, upstream TBB only support like large pages, only support on Linux, but I figured it will be like pretty straightforward to enable support on Windows too. And I think I can try to actually show the patch itself to TBB. It's pretty small actually. So there are two parts. First, first part is actually checking if large pages enabled and available, and
Yeah.
second part we just so they're allocating using the same function virtual lock. You're using to allocate like regular pages, but you need to just
Hmm.
pass additional parameter,
Yeah.
and basically that's all. And suddenly it was like it just works with this. I'll try to do pull request to TBB for this. I don't know if they actually agree to accept it, because like it will need to be supported and you need to write tests for this stuff and
Yeah.
all usual stuff, but I'll try eventually. So,
That's
and
cool.
on our side, basically, when we have large pages supported by TBB on our side, what I want to do is to inject TBB library into Factorio process and replace like default memory allocation functions like malloc and free with
Yeah.
two calls with TBB. So, and I successfully did this sort of with this patch. So let's just go through it. So the patch itself consists of two parts, which is launcher, which is used to launch Factorio executable and inject library, and the proxy library, which is just a library like we are actually injecting into the
Hmm.
process and which is linked with this TBB allocator.
Okay.
So in the patch itself, like it's just single file, and most of it is just main. Well, it's called impl, but we call it a simple just for main, and
Yeah.
just just to I'm getting this scene get just to, so the window won't close, like the console window won't close immediately, and we can
Yeah.
actually see what's going on. So there's nothing special. We're printing parameters, keeping the first argument, which is just our launcher exe name, getting proxy path, which is now hard-coded proxy DLL, and getting
Yeah.
Factorio exe. So by default, it's just Factorio exe, but I'm using like I'm passing parameters, and I'm doing this because from Steam I have custom launch options. Basically, the first part
Yeah.
is the launcher, and then command Steam will just replace this with a path to Factorio executable.
Yeah.
So then before we can use before we can use this like large pages, we need to call some Win API functions, like because like as I said, large pages are not very well supported on Windows, and basically one of the issues, they are always like they are not pageable. It basically means they are never offloaded to the page file. They always stay in physical memory, and this is sort of security issue, because potentially if you allocate too much, like too many large pages, the rest of the usual pages will be forced to swap, and your entire system basically just stops. But in practice, in practice, large page allocation will just fail much early, like before this actually can happen.
Okay.
So and basically, and because of this, to actually get large pages, you need this special privilege, which called lock pages in memory, and it's actually it consists of two parts. You need to you need to add this privilege to the user account, because by default, like no one has this privilege. Not even like admin account has this privilege. You have to add this, so like local policy editor, because
Oh dear.
Microsoft, of course. And
Yeah.
then after you did this, you need to also call those functions like lookup privilege and not just token privilege from your program to actually able to use large pages. And after this, there is a function called get large page minimum, which returns like minimum size of large page supported, or zero if they are not supported. And
Okay.
we can actually run Factorio, and immediately tells us that like that huge page allocation failed. So I have this next line where I allocate a single large page and basically and free it immediately just to check if large page is available. And like it returned like we have 2 megabytes pages, but we cannot allocate a single one. And that's because I can show you. So there is a tool called RAM map where you can see like memory state of the program. I need a few seconds to actually scan everything.
Yeah.
And so I have, it says I have 7 gigabytes of free memory and 14 gigabytes of mapped file. It's called mapped file, but it's actually like the file system cache, because Windows, when you don't have like when you have a free memory, basically Windows will use it for for file cache. So if you when it accesses files, it puts it into this cache, and will try to
That's cool.
yeah, that's cool, and it's generally a good idea, but and like and it's actually, so when you're allocating like the normal pages, it works fine. Like Windows just like flush this cache
Yeah.
if it don't have enough memory. But for large pages, for some reason, I don't know why, it's not doing this. And basically,
Oh.
we have we have like actually this tool also support some cleanup, so we can call empty standby list. I'm not sure why it called exactly that. And after this, we should have more memory available. And like we have 7 GB available, but we still could not allocate a single large page because like large page require like contiguous range of the physical memory
Yeah.
pages. So and it was too fragmented. So now we have how much? 21 GB, and it should work.
Yeah.
I hope.
Yeah. So are large
No,
pages more susceptible to fragmentation issues?
they they extremely susceptible to these fragmentation issues, and like now it's still failing.
Hmm. Yeah.
Uh,
Because I've not done a lot with handling manual sort of, or like working with C++ and memory management, but something that we recently tried looking into at work was changing the memory allocator, which some of our Ruby servers run because there's a JE malloc algorithm which is supposed to avoid fragmentation more. So we switched a few over to that.
yeah, but in
Yeah.
I have in this case it's fragmentation not even like on application level, it's fragmentation on
Mm,
operating system level. Basically, you actually
yeah.
you can see like uh, the actual ranges of available Windows just like to put allocate some like single page in the middle of the nowhere,
Yeah.
basically, and this range became no longer available for the
Mm,
allocation. So actually, I have a problem because oh yeah, it succeeded finally. So now it runs, and it basically it runs a benchmark, and it's so this is actually a bunch of debug logging from Factorio itself. So
mm,
it's it's like run a benchmark, and so now it should be yeah benchmarks doesn't make my like numbers doesn't make sense because much sense now because I need to reboot to actually gain any boost now because again of
okay.
fragmentation. But we can do something else
Mm,
if we remove all these benchmarks commands and just run Factorio usually. Yeah, it can't allocate again, of course. Uh,
uh,
please. And because of this reason, on Linux you have the option to like reserve physical range, physical memory
mm,
specifically for the large pages. So so they won't be like okay, it works.
sure. That makes sense. Hmm.
And well, if if I wasn't be able to run Factorio at all, it would be very embarrassing.
Yeah.
So let's wait. And we can use this RAM map tool to actually to see how much memory was allocated, how much large pages were allocated. I'll load Doge sushi save. 30 FPS UPS
Ouch.
without all streaming and capture it gives me about 50, I think.
50's not bad for that monstrosity.
So we can try to update and see if it get any large pages. So yeah, it's allocated. It's managed to allocate one page, but it's still. But at least we can
Yeah.
check it. It works.
Yeah. Is it possible to sort of tidy up the currently allocated memory?
Well, I'm pretty sure like from inside Windows kernel there is a code to do like physical memory defragmentation,
Yeah.
but I didn't manage to find any way to make this from user side.
Yeah.
So we can exit. And so I'll go briefly for the rest of the launcher. So for TBB to use large pages, we need to set this environment variable to, so we can, so if you want to check without large pages, we can just comment it. And we'll
Yeah.
run this TBB allocator, but without large pages. And actually, it gave by itself, it gave some marginally improvements on my machine.
Mm.
But like some other people who tested it, like they reported, they get nothing. It
Mm.
still maybe like makes sense to use the allocator. So the
Yeah.
rest of the code, we are getting kernel 32 loading kernel 32 library, loading like get load library a function from it, which needed for actual injecting. And we are starting here, actually starting Factorio process and just usual Win API create process. The only interesting thing is we're starting it in suspended mode, which basically means that the only thread which was created by default for the process will start in suspended mode, and we have to resume
Mhm.
it later. So then we're taking like proxy name, which is proxy DLL. And
Yeah.
we are allocating this like string containing this proxy name inside the
Yeah.
Factorio process. So virtual x function, it can actually allocate memory in other processes, not only in current process. So we are passing Factorio process handle. Then we are writing to this allocated memory our proxy name, proxy DLL. And
How does that allocation of memory and other processes work? Because surely that would require some sort of like raised privileges.
yes, actually, it's usually require raised privileges, but in case when we created this process, we actually have full access to this
Okay,
process.
yeah. That makes sense.
So we are allocating memory, we are writing this like proxy DLL string to this memory, and then we are calling create remote thread for this, which basically create remote thread accepts thread function
Hmm.
and this thread function, it's exactly like this function definition of thread function is exactly the same as this load library function. So we can just pass load library directly. There is some interesting part because we are getting address of function in our parent process, but we creating thread in remote process with this pointer, and this will usually crash, but kernel 32 library is special. It is always allocated on the same address inside in all processes.
Okay.
So we can do this. So we are creating this thread. We are waiting until this thread like finished, and then we are resuming the main Factorio thread, and it can continue actual like work loading Factorio, and then we just wait for Factorio to exit.
Mm-hmm.
And this is the launcher part and the proxy part. So Windows DLL have some special function called DLL main, which called in different circumstances, but only like case we interested in. It's called when this library actually loaded into the process.
Yeah.
And in this code, basically we are replacing this allocation functions. Like
Yeah.
it would be much more easier if those functions. So Factorio itself is statically linked to the
Mm-hmm.
runtime, and it's not easy to find like functions using get proc address or something like that. So what I'm doing, I'm searching for the specific byte signatures of this functions inside
Okay.
inside the process,
Right.
and then I'm basically inserting a trampoline, and trampoline is just like jump, like it overrides few initial bytes of the target functions with jump to our patched
Yeah,
functions.
that makes sense. That's
And actually, what this find seek part is the problem, is the issue why it won't work with different versions, because these byte signatures will be different for each Factorio versions. Well, I think they
okay.
will be mostly the same, but they also contain some offsets called PC relative offsets. And
Yeah.
they won't work. So we can actually just switch to 81 and see.
Hmm.
And yeah, it's immediately crashed.
Yeah.
And it's crashed because we are calling an abort here, and
Yeah.
it wasn't managed to find.
Hmm.
Um,
So
yeah,
how does that sort of manipulation of the program at runtime work? How do you do that? Um,
you mean what exactly?
as in like the sort of so you're able to search through the
Oh,
program
oh
and
yeah. So there is a get model handle function which returns each model, like, and then you call it with null pair. It returns like handle to the current model, to Factorio XZ in our case.
Mhm.
But what this model handle is, in fact, is just pointer to the basically to the base address of the model. And
Right.
if we know base address and we know like module size, which is for now just I just hard coded it, we just go in a loop basically in
Okay.
doing memcmp, like with this signature.
Yeah.
And one thing
Yeah.
actually I want to add is to actually add print return code. So we will know if it actually crashed or returned normally. So let's try. Yeah, exit code non-zero, and it's this code itself. I think it's like exception code or something like that. But
Yeah.
basically, the only thing we are interested if it's zero or not.
That's cool.
And so now we need to know like updated signatures. I have a few ideas how to do this more generally than this. Like we can just
Yeah.
encode signature for each version and just go over them, but it's not very scalable.
No.
So I think I can try something more robust. But before we can do this, we need to actually know actual signatures.
Yeah.
And
Because surely
so
there's a pattern to it, and you can just
yeah, I
ignore the offsets.
and I have a general idea. So first of all, I just remove everything and launch Factorio normally. And then like Factorio actually, it's really helped that Factorio developers provide PDB file for Factorio exe. So we can actually attach to the process and
That's
see
cool.
functions and things. So
I guess that helps.
So this is WinDBG. Like I don't have Visual Studio installed, but I don't like Visual Studio anymore. Anyway, so
I'm not sure anybody particularly likes Visual Studio.
now we just need to find Factorio here. And we need to set a breakpoint on some interesting function, let's say malloc. So
Yeah.
it will be should be something. Just Factorio. Yeah, it should work. So now we should be able. Yeah, and it's like successfully breaked on malloc. So we have a call stack, and it's actually I'm only proxying the malloc functions. I'm not proxying new, but in Microsoft runtime, new just calls malloc under the hood. So
Yeah.
we don't need that. And malloc function itself in Microsoft runtime is just like simple wrapper for the functions malloc base. So it's just single tail call jump. We can step into and we can see actual assembly of this malloc based functions. And here those bytes is those actual bytes I'm using as a signature.
Yeah.
So I have saved the signatures from the previous versions, so we can actually compare them. So let's do this. So actually, at least for this signature,
Yeah, they look the
bytes
same.
are completely identical. So this good.
Yeah.
It's good. I guess I didn't capture like the entire thing. Uh, so let's just okay, and here. Oh yeah, I see now where it's different. So few bytes here.
Yes, the fourth to the bottom last.
And basically those bytes they called PC relative offsets, and basically
Yeah.
they're accessing like relative to the current program instruction pointer. And basically if you change anything, if you change something in your source code, like your function size will change, or your linker decide to put things in different order, and basically your offsets will change.
Yeah. Makes
So now we have this data. So and now you're going to see why I should have learned Vim when I have a chance. So I need to convert those bytes to the string into the string like this.
Yeah.
And how I'm going to do this? I, I'm not proud of this.
Oh dear. No.
I probably should have written some script to do this automatically, but no.
I mean, I'm surprised your tool doesn't have a better way of getting that string of bytes out.
Well, actually, I think you can extract it. better way. At least try to do this.
Yeah.
What is this pointer? Yeah, you can copy. I only need to find actual where it actually ends. I guess I can. Did it work?
It,
Oh, yeah. I forgot the comma, but so yeah, and it worked.
cool.
We need few more bytes. So yeah. So but before we now can just kill the process.
Yeah.
But before we actually replace it, we need to do something more. So I want to check if actually our new signature is actually works before rewriting everything. So I'm
Yeah.
doing, we'll just comment everything. I think we can do this. So we will only check this malloc. So now it should crash. Oh no.
Yep.
I need to copy script back. Okay, of course it's failed. We can just, I guess, disable for now. It's not important.
Yeah.
Yes, it crashed. And if we replace the signature with new one, it should work. Yeah, by the way, I'm doing local recording too, so are you okay if I put it somewhere later?
Yeah, that's fine.
Okay. Okay, it now and now it works.
Yeah.
So, but
Cool.
we need like obviously I do not want to do to store this like individual signatures for each version, and
Yeah.
it's not even a final 81 version, so it'll probably change. So I need something more smart committed
Yeah.
for this. And so what I wanted to do, I actually add a mask, basically, so I can ignore some bytes.
Yeah.
And there is two ways to do this. Either like store byte mask as a separate array, but it means basically copy pasting this entire line and uh, and replace like writing mask manually, or I can actually extend this instead of char using short, and I will use like special value to store the mask. And we will need to change memcmp stuff to something different, but that's okay. So now we just need to find bytes which are different
Hmm.
and replace them with placeholder. Okay, that's all. And now we need a different mem comparison function.
Yeah.
Silent short. So if signature equal to p, I'll just ignore it. Otherwise, if signature not equal to actual data, we should pass
Mm.
char const
Mm.
false, and if here return true.
Yeah.
And here we need to replace Pig. Okay, let's hope. Oh, wait. Already had this pointer. Should be okay. I'll just remove const. And now it doesn't compile because oh yeah, we need to change it to. Now it doesn't like memkmp mask because
Is it because it's a
it's what's actually happened? Okay. Yeah. And now if we run this, it works.
nice.
Yes, proxy dealer was installed. So now the most exciting part, repeating the same process for like remaining 4 functions.
Yeah.
And it's actually funny because in Microsoft runtime there is a function called recalloc, which is exactly like reallocc, but it's also the memory, and it's called exactly once from the Factorio.
Yeah.
So let's just keep adding those pointers and see what happened.
Yeah.
We need to change signature. Well, it works.
And surely until it tries to
Maybe bytes won't change it. So let's just wait. Did I?
No, it should fail if it's not matching.
Yeah, this is failing. So
Yeah.
okay, this signature didn't change, so it's easier for us, I guess. So let's
But
go.
surely it might change in the future though.
It might, and I guess I'll just fix it then.
Fair enough.
And this also works. Just so I also do some quick check. Yeah. Okay. I guess it will be easier than I thought.
Well, I guess you could still look at the
like I still can look into the actual disassembly and see for those,
Yeah.
look for those offsets.
Yeah.
But yeah, I will think about it later. Okay, free doesn't work. So I guess we are doing same thing again. Removing this, running, and touching. Okay. Yeah, we need to go into the free base, I think. So let's see how it's different from the previous version.
Got one of those change pointers.
Oh yeah, here. And here, yeah.
Yeah.
A lot of things changed, but should be enough. Should be easy.
Yeah.
Oh yeah, and yeah, we need a few more bytes. So we should so let's find those bytes. Okay, seems this is enough. Yeah, we need to stop, and we need to copy script back. Okay, it seems to work.
Nice.
And finally, recalloc. So let's see. Oh, recalloc also work. Nice, nice.
Easy.
And this should be it, actually. Yeah, oh yeah, and by the way, the return code was 0 as expected. So we should uncomment all of this and it should just work. I hope.
Ah,
Yeah, I'll try to load safe
nice.
and if it works, I assume it's done.
Hopefully.
Yeah, it works.
Nice.
Exit code. And that's basically it. So it works now.
Cool.
So yeah, regarding like what to do with memory fragmentation and all this stuff. I have a couple ideas. Like the easiest solution, just move to Linux, actually. You don't have any of those problems. But
Yeah.
I have I have two possible solutions. Both of them actually stupid. One of the solutions is actually it is to write a device driver and basically from write a kernel driver. From kernel driver, like you have full access. You can allocate physical memory directly, and you can provide your
Yeah.
own allocation functions. You can reserve memory. You can do whatever you want. I have zero experience with drivers, and also it's even more complicated because my like Windows can only load a signed driver. You need to sign it, and you can use self-signed drivers like for testing, but to get driver actually signed, so anyone can use it. Basically, you need to pay money to Microsoft.
Mm.
And
Couldn't.
yeah, and second solution, which is even more stupid, is to basically have a special program from user mode, basically which runs at the beginning at the startup and just allocate a huge chunk of large pages while you don't have like this much fragmentation. And then I checked WinAPI like reference, and it seems you can share like memory. So you can share memory between processes, and it seems you can do this with large pages too. So basically, you have this separate process which works all the time, which keeps these pages allocated. And basically, if some other process requests pages, it can share it with this process. And when other process like deallocates pages or dies, it return pages to common pool and can give them again. I'm not sure
Yeah.
if I even tried to actually code this. It's, but I may or
Yeah.
may not.
Yeah,
So,
I think from a sort of humorous standpoint, the that having a driver that sits and defragments the memory simply for running Factorio would be quite humorous.
well, I think this is pretty much in vein of the type of challenges we are doing on this challenge on
Hacking
this channel.
Factorio.
Yeah.
So anyway, I am not sure if I haven't tried to implement any of those solutions.
Yeah.
So yeah, thank you, thank you for visiting this. I hope this was useful or just
That's
entertaining.
cool. I've it's I'm on Mac OS, so I'm now thinking about implementing the same, but
Well,
for Linux.
well, for at least for Linux, there are I saw like multiple already working solutions on the net. Basically, you can
Okay.
you can use LD preload to like inject memalog library inside Factorio process, and it will
Hmm.
replace malloc, like all these locations functions which its own with it, and it can use large pages. And I think this should work on Mac too. And
Okay. Yeah.
actually, do you have M1 or Intel Mac?
Yeah.
Because on M1 processors,
Yeah.
I think default page size is 16 kilobytes, so it's already like
Okay.
4 times better.
Yeah.
But you can
Uh,
you can still try. It will be
uh,
much easier than doing this binary patching.
yeah. That's cool. Hmm.
So yeah,
I know. Thank you
thank
for
you.
going through that.
Okay, I guess I'll stop recording and sharing.
Yeah.